So imagine having a digital version of something real like a building, a car, or even your own body that's showing you what's going on with it. Welcome to the world of digital twins. So in this video, we'll be taking a look at what they are, how and why they're used, and we'll be taking a look at the near future of digital twins as well. So what is a digital twin? Well, it's a virtual clone of a physical object or system that's updated with real-time data, okay, and uses simulation, machine learning, and reasoning to help make decisions. It's designed to mirror everything a real-life object does. So if you have a car, it's going to show you how fast it's going, how much fuel it has, even if there's a problem with the engine, okay, all in real time. It spans the physical object's life cycle from inception to decommission, and it allows for constant simulations and analysis that can improve the ongoing performance and efficiency of the product. So what are digital twins used for? Well, they're used in a number of areas and it's expanding all the time. So in effect, they'll be helping companies work better, work smarter, solve the particular problems that come up either routinely or out of left field, and even predict issues before they happen. So as a first example, we can look at manufacturing, say car manufacturing. The digital twins in this environment are used to create multiple simulations of the entire production environment. So we're talking about design, manufacturing, and maintenance. So it can simulate different scenarios to have a look at what changes can do to the production environment. For instance, if they change the order of assembly or they introduce a new part, they can in effect see via this digital twin how that's going to affect the outcome. So as a result of this, it's used to identify potential issues, optimize designs, and reduce production costs. Overall, improve the vehicle performance and enhance production efficiency. A second example might be in the healthcare industry, where digital twins create a holistic view, I mean an entire view inside out of the patient based on their individual characteristics, their medical records, which may come from electronic health data, medical devices, and wearables. And keeping in mind, this is all real-time data, okay, so it's up to the minute. So an application of this might be where we take a patient with a chronic heart condition and we create a digital twin of that patient's heart. So we'll get real-time data, that's up to the minute data, from the patient's electronic health records, medical devices, and any wearables. It'll basically show how the heart is functioning in real time and help doctors and medical staff plan surgeries and intervention as needed. So it's used for doctors, in effect, to predict how the heart will react to different treatments, given that it's a scenario-based system, and making surgery safer for that patient and potentially more effective. It'll allow continuous monitoring of the patient and hopefully will reduce the instances or the need for future hospital visits. So another great use of digital twins is in smart cities. You may have heard of this concept before. What it is that we take a digital model of a city and we integrate real-time data from the physical object in order to simulate traffic patterns, to look at things like traffic light management, public transportation, and the general flow of traffic. So by simulating the city in the digital twin, we're enabling planners to adjust signals and reduce congestion, basically. And as a result of that, fewer traffic jams will be predicted and smoother commutes will result. They can also simulate the impacts of environmental factors like heat waves, snowstorms, dust storms, etc., to see whether the infrastructure for the cities is actually sustainable and resilient to those events occurring from left field. So this will also assist in the ongoing preventative maintenance of the city's infrastructure and the city assets, minimising downtimes and operational issues that might come about by any of these events we were talking about. So what's the process of actually creating digital twins? Well, this involves several steps, the first of which is data collection. This is where we're gathering data from the physical object using sensors and the Internet of Things devices that monitor the various aspects of the object, such as temperature, pressure, movement, and other relevant metrics that may allow the replication and mimicking of behavior, functionality, etc. So the second step is the virtual representation of the digital twin. So this is where the collected data from the first step is used to create the virtual model of the physical object, which is often a 3D rendered representation or a set of drawings in effect that accurately reflect the real world counterpart. So this digital model will include the object's functionality, features, and behavior. The next step will be the simulation and modeling. So once that virtual model is created in the second step, advanced modeling and simulation software is used to simulate the behavior of that physical object. So this involves running various scenarios which are known and perhaps not potentially envisaged, but need to be tested to predict how the object will perform under certain conditions, as I said before, under extreme weather conditions and manufacturing anomaly conditions, new processes in place, orders swapped around, etc., etc. So in effect, this simulation will help with the identification of potential issues and optimizing of that performance. So finally is the real-time data monitoring. So this is where the digital twin is continuously fed with data from the physical object, which have the sensors and the Internet of Things devices attached to it to be able to feed that data through to the digital twin or the virtual model. So the data coming through from the physical object via those sensors and Internet of Things devices ensures that we're getting a current, up-to-date reflection of the state of that physical object. And of course, this allows for ongoing monitoring and analysis of the object's operations and performance. These digital twins can be accessed remotely, which is probably something you would expect, and enable users to monitor and control the physical object from anywhere. Okay, this is particularly useful for managing complex systems and facilities. So a backbone of this digital twin technology is that we're leveraging artificial intelligence and machine learning for the visualizations and accuracy of predictions that we require for this. The AI and the machine learning itself helps process very large volumes of data, which will be required, as you can imagine, on an ongoing basis, and provides insights to that performance for optimization and predictive maintenance. So in a nutshell, this digital twin technology provides a comprehensive virtual environment that mirrors that physical world, allowing for that enhanced monitoring, analysis, and optimization of products and services in various industries. So what's the future for digital twin technology? Well, it's actually poised for significant growth. It's expected to increase from $12.8 billion investment in 2024 to about $240 billion by 2035. That's pretty significant. So in terms of technological advancements for digital twin technology, it's expected that there'll be more integration between digital twin technology and artificial intelligence, as well as quantum computing. And what this will actually allow is the handling of more complex systems with much larger data sets, okay, to operate more efficiently. So this will actually enhance the predictive capabilities that we currently have, but on a much larger scale, and it'll be able to handle more sophisticated simulations. There will also be the development of autonomous digital twins, which basically is where the digital twin technology can operate without human intervention. So this is where we expect that it'll further leverage the artificial intelligence and machine learning technologies to optimize operations and maintain everything autonomously, okay, without that human intervention. So that's a big step. We'll also be seeing it more on the sustainability and climate change side, where we will be optimizing energy use, reducing emissions, and simulating climate change scenarios more often to inform of public policy and planning. So then again, that would be an expansion of the current capabilities that are currently in place. And of course, education and training, as you can imagine, will benefit from digital twin technology by providing dynamic, personalized virtual learning experiences for skills development. So if you learnt something today and you liked this video, please like and share it. Subscribe to my channel. Watch some of the videos that I've put up on this page. And until the next time, stay informed.